welcome to Teacher Gimble's Classroom. Today we're going to be going over Illustrative Math, Algebra 1, Unit 1, Lesson 11, Practice. If you have any questions, as always, leave them in the comments below, and if you like this video, please like and subscribe so I can continue to make more of them. Let's get started. Problem number 1. In science class, Claire and Lynn estimate the mass of 8 different objects that actually weigh 2,000 grams each. Here are some summary statistics. Claire had a mean of 2,000. Lynn also had a mean of 2,000. Clara had an MAD, or a mean average distance, of 275. Lynn's mean average distance was 225. Median for Claire was 2,000 grams, and the median for Lynn was 1,950 grams. The IQR for Claire was 500 grams, and the IQR for Lynn was 350 grams. Which student was better at estimating the mass of the objects? Explain your reasoning. So, the mean doesn't really matter because they have the same mean. The median is pretty close to the mean for both of them, so I'm going to disregard that. However, we have a pretty dramatically different MAD, and we have a pretty dramatically different IQR. What we notice is both for the MAD and for the IQR, Lynn's values are less. The mean average distance, it means that she has less variability, that her data in general is each value is closer to 2,000 than Claire's, whose data is farther away from 2,000. The smaller IQR says the same thing, that the interquartile range for Lynn is smaller, so in general, her data is closer to the median than Claire's data is closer to the median. Because of these two values, we can conclude that Lynn was better at estimating the mass of the objects, and that's because the variability was smaller based on the MAD and the IQR. Let's go on to problem number 2. A reporter counts the number of times a politician talks about jobs in their campaign speeches. What is the MAD represented at the data of the dot plot below? So first, we need to figure out the mean. The mean in this case is we add up all of the values, which we can get by the dots. There are 3 5s because there's 3 dots above the 5 button. The same with 6. That's 4 6s. So 7 and an 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points here, which gets us 7 plus 15 is 22. 28, 34, 40, 47, plus 8 is 55. 55 divided by 10 is equal to 5.5. This is equal to our mean. We now have to calculate the average distance for each number. So let's go ahead and do this over here. 3 is 2.5 away from 5.5. Because I say 5.5 minus 3, that gets me 2.5. 4 is 1.5 away. 5 is 0.5 away. 6 is 0.5 away, but in the other direction. But remember, with average distance, because it's a distance, our values will always be positive. 7 is 1.5 away. And 8 is 2.5 away. So those are our average distances. And to find the mean average distance, we're going to have to add them up and take the average just like we did above. Now notice I'm putting down 0.5 3 times for the 5 value plus 3 times for the 6 value. That's because I need to put it down for each data point, and we're going to divide it by 10. 2.5 plus 2.5 is 5, plus 1.5 and 1.5 is 3, so that's going to be 8, plus 1, 2, 3, 4, 5, 6. 6 times 0.5 is 3, which gets 8 plus 3 is 11. That's going to get us 11 divided by 10, which is 1.1. Feel free to pause this video to slow down if you need to review this a second time or identify the mental math that I did in the problem. If you have any questions, put them below and I'd be happy to do it for you. Because taking the mean of this got us to 1.1, our MAD, or mean average distance, is going to be 1.1 mentions. Let's go on to the next question. 4 amateur miniature golfers attempt to finish 100 holes under par several times. Each round of 100, the number of holes they successfully complete under par is recorded. Due to the presence of extreme values, box plots were determined to be the best representation for the data. List the 4 box plots in order of variability from the least to the greatest. Okay, we can do this. Well, let's think about this. The least variability is going to be the one that has the tightest amount of data. So let's calculate our mins, our maxes, and some of our IQRs. This has the smallest IQR. This one has the largest IQR. However, 43 to 67 is going to be a difference of 24 versus 40 to 58 is a difference of 18. Here we have 42 to 65, which is a 23 distance.